Hello guys, welcome to a different segment of Edupact Online called Edupactivity. We will be looking at a sample WASI core math question. We have the question here. Length BD is a chord of a circle ABD and we have a radius of 10 centimeters. We also have been given angle BOD to be 120 degrees and we are asked to find the length of the chord BD. Before we start looking at the question, let's look at some pre-tips to solving math questions in general. First, we have to stay calm. And second, given the question, we ask ourselves, what topics are related to it? Then we go on to dissect the question into various forms related to the topics before we even attempt to solve the question. Now let's see some recommended solutions. We are going to look at this in two forms. To look at the first form, I will assume we are now calm to solve the question. So then we ask ourselves, what topics are related to the given question? Here we can see a circle, so we can think of circle theorem. We have angles, and then we have trigonometry related to the question. Now let's dissect and solve the question. We have triangle BOD to be an isosceles triangle. How do we know this to be an isosceles triangle? Because we can see that the length or side BO, which is the radius, must be equal to the side DO. And we know that isosceles triangle have two sides to be equal, with the angles also being equal. Now, one thing we can do is to equally divide angle BOD by drawing a straight line through the angle and making sure it touches the chord BD. So we can see that we have formed a half triangle within the triangle BOD. We can call the half triangle BOP. Let's label this part as P. Now let's solve triangle BOP separately. So we have triangle BOP and you have angle BOP to be 60 degrees and then we have side BO to be 10 centimeters. Now, in order to be able to find the chord BD, we would have to find the side or length BP. Using the trig function or the SOHCAHTOA function or technique, we can see that we can have sine of an angle should be equal to the opposite of the angle divided by the hypotenuse of the angle. Here we have sine 60 and the opposite is going to be the length BP divided by the hypotenuse, which is the side BO. So to change subjects, we can have the side BP to be equal to 10, which is for BO, multiplied by sine 60. Should we punch this in our calculators, we are going to have approximately 8.0 17.66. But let's not forget that the side BP is just half of the chord BD. So to find BD, we would have to multiply 2 by the side or the length BP. So we have 2 times 8.66, which gives us approximately 17.32 centimeters. Let's now look at the second approach, which is more concise. For the second approach, what we are going to do is to follow the cosine rule. And for the cosine rule, we are going to see that the side or the chord BD squared should be equal to side BO squared plus the length DO squared minus 2 times BO times DO multiplied by cosine of an angle given. So then in this scenario, we are going to have BD squared to be equal to 10 squared plus 10 squared minus 2 times 10 times 10 cosine of 120 degrees. So we are going to have 100 plus 100, which is going to be 200, minus 200, and then we have cos 120 to be negative half. So this adds up to 200 plus 100, which is equal to 300. So we know that the side BD squared should be equal to 300. So then to find BD, we have to take the square root of each side. So BD should give us approximately 17.32 centimeters as well. Thank you very much.
For more educative content, subscribe to this channel and follow us on Facebook at Edupact. See you in our next video. Until then, stay safe.